Staring at my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to take a look at incremental development in Python. And specifically, we're going to be looking at breaking our programs into multiple functions, as well as breaking them into multiple files. So what is incremental development? Well, incremental development is a software development technique that involves breaking a problem into smaller, more manageable parts. And there's a few ways we can do this. One of those is functions. Functions can be used to encapsulate these parts, allowing for step-by-step implementation and testing. They also allow for reuse, so if we solve some of these smaller, more manageable problems, we can then reuse them in our future programs. The other technique we're going to take a look at is how we can split our programs into multiple files called modules, and then reuse the functions defined in these modules by importing them. The first technique we're going to take a look at is splitting our code into multiple files. And Python allows us to organize our code across multiple files it calls modules. And this is great because it enhances both the readability and organization of our code. We can split related functions into one file and then import them for later use. This makes our code far more maintainable and reusable. By maintainable, we mean it's easier to find bugs and solve bugs, as well as if we were using this code again in the future, to add new features to it and understand the code. So this allows us to separate functionalities and reuse code effectively. So if we make a file of really useful functions, we could then use them across multiple programs. Let's take a look at an example. Here we have a program called my_math.py, and this has two simple functions defined in it, add and subtract. Add simply adds two numbers, and subtract subtracts two numbers. Maybe these were useful functions that we want to reuse in other programs. Well, we can do that. Here's a new program called main.py, and it contains an important line at the top. This is the import line. And we've seen something like this before when we were importing the math module or importing the random module to access the functions defined inside of it. Well, we can do the exact same thing, but with our own files or modules. So in this case, we're importing both the add function and the subtract function from the myMath program. So an important thing to note here is the name of the module. It has to name the name of the file. And when we're working with simple cases like this, these have to be inside the same directory. So if we want to import myMath, the mymath.py has to be defined in the same directory as main.py. Once they're defined in the same directory, we can simply import them by giving the file name in the import line. Except keep in mind that we don't add .py here. We don't add the file extension. So the name of the module is just the name of the file without the file extension. So now if we were to run main.py, we would actually be able to use the add and subtract functions from mymath.py. And if we would run it, we would get the result that's currently showed on the screen. We're adding 5 and 3 to get 8, and we're subtracting 4 from 10 to get 6. So one important detail that we have to pay attention to when we're defining our own modules is that any lines outside of a function are going to be run when we import that module. So in this case, we added a few print lines to mymath.py to sort of test and debug the output. However, when we import it now to main.py, we get some output that might be unwanted. Here we have all of that testing and debugging output from mymath.py, and this is caused by importing the module. Even though we may have only wanted the add and subtract functions so we could use them in our code, we're still getting this unwanted output. And this is coming from these lines here because they are outside of any function. So keep in mind when you import your own module, it's going to run any lines that are outside of a function when you import them, in addition to getting access to those functions. So there is a way to resolve this problem, and that's with the statement here that uses the name global variable. The name global variable is a special variable that basically returns the name of the file you're currently in, or the name of your module you're currently in, to be more accurate. Now, there is a special case. When that module is the one that you're running directly, the name changes to --main dash dash. So this gives us a way to detect if this module is being run directly, like someone's actually hitting that play button in PyCharm, or if it's being imported by another module. If name equals underscore underscore main underscore underscore, we know it was run directly. So this allows us to include some debugging and testing output like we just saw in a way that will only be run if we're running the file directly and not if we're importing it. So we could improve that last example by adding this if statement here. Now, this if statement is going to check if this file is being run directly, for example, hitting the play button in PyCharm, or if it's being imported by another module. Only if it's being run directly are we going to execute these debug lines that should show a few runs of the add function. These won't execute when it's imported. So now in main.py, if we import this math module, then it won't output those lines. We just get the addition and subtraction. We just get the functions we want. So when you're designing modules to be imported by another program, it's very important to make sure that you wrap any lines that are outside of functions in a block that looks something like this, where we're checking the value of name. So to summarize, it's generally good practice not to include code outside of functions or outside of an if statement that's checking name if this module or file is going to be imported by another program, because we don't necessarily want those lines to execute when it's imported. We may only want access to the functions. The only exception for code outside of functions in a module like this would be if we're defining constants that we want to import into another program. For example, the math module defines constants like the value of pi. The next topic we need to discuss is the main function. In many programming languages, it's common practice to define a main function that acts as the entry point or starting point for our program. In many of the examples we've seen so far, we just sort of start at the first line and keep running line by line. But when we start getting into functional programming, we can have function calls that sort of jump all over our file. Having a main function makes it easier for the reader to understand where this program is actually starting and where the logic begins. This helps us organize our code and makes it far more readable. And that means it's far more maintainable and far more reusable. Now, it's important to note that this main function has no special meaning in Python. It doesn't run by itself, it doesn't automatically call this function or anything like that, and it has no special meaning defined in Python syntax or grammar. It's just a function like all other functions. This means we still have to call it manually. In the example we can see on the screen right now, we have a very simple program that just outputs welcome to the program. However, instead of just having one line, print welcome to the program, we actually have a function called main that has the logic of our program in it. Then we have a call to main that actually starts the program. Remember, the order here is important. The call to main has to occur after the function is defined. Now, this is a good start, but what if we wanted to reuse the functions in this module? In that case, calling main at the end might be a problem. This could be a problem because it means when we import this module, the main function is going to run right away. So there is a way we can fix that we've already seen, and that is checking the value of the name global variable. So here we added that if statement that we saw before, and by wrapping our call to main in this if statement, it means that we're only going to start the entry point of our program, we're only going to run the main function if we're running this module directly by hitting like that play button in PyCharm, for example. If we're running this code in another way, such as importing it from another module, it means this call to main won't happen and we won't actually execute anything. We'll just import the functions so they can be used in another module. This is great when we structure our code this way because we don't have to worry about indenting all of the logic of our program under this if statement. We just simply have a call to our main function. And we know that this main function is where everything starts. So this is a very common structure to see in Python programs. You often see modules that have a bunch of functions defined. One function's the main function, and at the end you'll see something like if name equals main, then run the main function. And it's also a structure we should try to replicate in our code, especially if we're going to be importing the functions into another module. In addition to splitting our code into multiple files, another key part of incremental development is splitting our code into multiple functions, breaking down a big problem into smaller, more well-defined problems. But one of the problems you'll face is you'll often know which functions that you need to make to solve your problem, but you haven't written all those functions yet. And if you try to run the code before the function's defined, you're just going to get errors. So that can make it hard to test the functions you have created already. Python has a solution for this in the pass keyword. The pass keyword simply acts as a placeholder. It doesn't do anything on its own, it's simply ignored, but it does allow us to define functions without any code in them until we're ready to create them. This helps us maintain our code structure while we're developing incrementally. Let's take a look at an example. In this example, we're trying to make a module that has a bunch of different functions related to basic calculations. Things like addition, subtraction, multiplication, and division. We also have a little example main function that right now just prints calculator ready. Currently, maybe we're still working on writing this program. We know we need an add function, a subtract function, a multiply function, and a divide function, but we haven't coded them yet. We've just created their function headers. Now, normally, if we just gave the function header and no code after it, we'd get an error because there's no code in that code block. But what we can do here is add the pass keyword. And this just tells Python this is a placeholder, don't do anything, but it does count as a code block. So that means we won't get an error about the add function or subtract function or multiply function or divide function having no code block in it, because pass is treated as a statement, even though it does nothing. So to summarize, when we add the pass statement and it's executed, nothing happens, but we avoid getting an error when empty code is not allowed, such as in a function or in a loop. Now we're going to get into a more interesting example of incremental development. So we have an example problem here, and we're going to try to solve it in PyCharm using an incremental approach. And the problem is we want to create a module named calc for a calculator that provides functions for addition, subtraction, multiplication, and division. We also want to include a function that prints out a menu for the user, as well as takes some input from that menu. This menu should display options like, do you want to add numbers, subtract numbers, multiply numbers, divide numbers, or do you want to quit? And we should keep taking input until they say they want to quit. Now in a second file, we want to import this calc module and then use the functions to actually ask the user for input and run the logic of the program. So the calc module is going to have definitions for our functions, but it's not going to have any code to run it. And then our second file, maybe we'll call it main, is going to import the calc module and actually make use of those functions. And overall, we should get a solution that has output that looks something like this. So first, we can see that it's outputting a menu, input your operation. We give the user a list of different operations they can select from, or X for exit. They input the letter for their selection, and then it asks us to input the numbers, and then it performs that operation. So in this first case, we're inputting 30 and 12, and it's adding them together because the user selected addition. In the second case, we can see that it immediately asks the user again for their input, and they're saying C for multiplication. They input 5 and 7, and they get 35. Then lastly, they input an X to exit, and the program exits. So we want to create this program with all these different operations available to the user, and it's going to keep asking them until they exit. So let's now switch over to PyCharm and see how we can code this. Okay, here we are in PyCharm, and I have two files created, calc.py, and this file is going to contain all of our functions, like the addition function, multiply function, and so on. And we have main.py, which is going to contain the main logic for our program. Now note that the names here don't really matter, other than that's how we're going to refer to these modules if we have to import them. Main.py doesn't do anything special. So we're going to start off by sort of breaking this problem into smaller problems, which is going to be a function for each operation. Now, maybe we don't know how to code those operations yet. In reality, they're pretty straightforward, but in a more complex program, we might not know how to code them yet. So what we're going to do first is sort of create the interface, where we're going to define all the functions and the parameters they're going to take, and we're going to use the pass keyword to not implement them yet. So we're going to get started with the add function, and that's going to take two parameters, A and B. And because we don't know what we're going to put in it yet, we're just going to use pass. So I'm going to fast forward this bit, but I'm going to type out the function headers for all the functions. Okay, we now have all our functions defined, but inside of each one is just the pass keyword. So these don't do anything yet, but we have an idea of what functions we're going to have. So now we can switch over to main, and we can start figuring out how we're going to format this. So the first thing in main, we know that we are going to import from calc, and that we want to import all the functions. When we know we want to import everything from the module, we can just use the asterisk symbol, which means import everything. So all the functions, any variables that are outside of functions, everything in calc. And we're going to try to do good practices. So we're going to have a main function. Maybe we don't know what's in there yet, so we'll say pass. And we know we're going to want to call that function. And we're going to protect it by wrapping it in a check to make sure that this is the module that's being run, if we're going to run it. So remember, this is saying the current module name, if it equals main. It equals main if we're running this directly, like if we hit the play here. Then we're going to run main. If this was imported, on the other hand, then we wouldn't run main. This probably isn't a big deal for this one because we're only importing calc. We're not importing main. But for still, to maintain good practices, we'll wrap it like that. So now we have an idea of what the structure of our code is going to be. We're going to have these different operations. We're going to have a menu that prints out a menu to the user. And we're going to have a main function that actually calls on that. So let's get started with this menu function. And this is what we mean by breaking the problem into smaller problems and then developing it incrementally. So the first increment we're going to make is the menu function. And that was going to print out to the user a few things just to give them some choices. So we're going to use print for that. And this is just going to be a bunch of print lines, so I'll fast forward this too. Okay, we've now have all our print lines. This is going to display the menu to the user and add an extra line break to give us a bit more space. We'll also make this function take in some input from the user. So we're going to store that in user input, and we're going to use the input function to get their input. Just say selection. And then we're going to return that user input. So we print out the menu to the user, ask them for input, and then return that input. So we've got the whole menu system contained in our nice menu function here. Now, the user could do something silly like add some spaces at the end or the beginning, or they could type it in lowercase instead of uppercase. So we're also going to clean this output a bit, and we can do that with some of our string functions. The strip function removes any leading and trailing space, so if they accidentally hit space and then A, it's going to get rid of that space. The other function is lower. So we're going to convert whatever their input is to lowercase. So if they put in capital A, it's going to be turned into a lowercase a. This will make it easier to deal with once we get this output back from the menu function and our main function. So now that we have the main function defined, we could actually test it out, even though we haven't coded anything else yet. So in our main menu right here, or our main function rather, we will call the menu function. And then this will just give us an idea to see if it's working, even though we're not really doing anything with it yet. So we'll run main.py. That should cause this call to main to trigger. Run our main function. I'll call the menu function. We should go over here and print out our menu. Let's see if that's working. That's a bit bigger. So we can see we get our menu and we can input a selection. Let's say we do D. And right now it's not doing anything with it. If we wanted to output what the result is, we could always wrap this in a print. And we could give that a run. So now we can see what we actually input. In this case, we'll put in a B. And we can see we get back a lowercase b because we converted it to lowercase. We can also try running that with a bunch of spaces. And a C, another bunch of spaces. And we can see the spaces are gone. We just get the C because we use strip. So that way we were able to test and implement the menu without implementing the rest of the program. And it's great to write our code incrementally like this because it allows us to focus on one part of the problem at a time and actually test that as we go. If we write the whole program out at once, it's going to be really hard to debug and test. So now we can move on to implementing these other functions. Now most of these are quite simple. In a more complex program, they might take more time to develop. In this case, they're just going to be simple operations. So we return a plus b, return a minus b, return a multiplied by b, and we'll just make that smaller for now. And we can return the division. Now, the division does have a special case, and that is if b is 0, this is going to cause an error because we can't divide by 0. So maybe we want to check for that. So say if b equals 0, then we'll print out an error. And we'll just return. When we give no value after return, that means it's going to exit the function and return the none value. So divide is going to print an error and return nothing, none value, if we input a 0 for b. Otherwise, it's going to divide a by b. So we have our main functions here. Now we can test them out before we actually use them properly. So we can just do some print lines here. Say add 10 and 5. Let me try printing out subtract 10 and 5. Try printing out, next one was multiply, I believe. So 10 and 5, and finally divide. So we're giving it 10 and 5 for each one, but we should get different results. We can see if it worked. So we got 15 for addition, which makes sense. We get 5 for subtraction, 10 minus 5 is 5. We get 50 for multiplication, 10 times 5 is 50. And we get 2 for division. 10 divided by 5 is 2. We can also test out that special case for 0. See, we get error, cannot divide by 0, and then the value returned was none. So again, developmenting the functions one at a time like this allows us to test them before we integrate everything together. So now that we have all of our functions created, we can now integrate, and that means combine them together to actually solve the problem. So we're going to get rid of all this testing, and we're going to start actually making the logic of the program. So in this case, we wanted our program to keep inputting values from the user, their menu selection, until they input an X. So we're going to use a while true loop, which is going to keep running forever. And in this loop, we'll have a special condition that's going to trigger the loop to exit. But first, we have to get our selection from the menu. So selection is going to be a variable where we store the selection of the user. And we're going to get that selection now by calling our menu function. This is really nice because we don't have to write out the whole lines for printing the menu and doing input and cleaning the input. That's all handled by our menu function in calc. So we don't have to write it out multiple times. We don't have to worry about it. If it's in here, we've debugged it already. We can assume that it's hopefully good. So that's going to get the value from the user. It's going to return the value and store it in selection. And now we can do some tests on selection. First thing, we want to check if it's equal to that X character. If it's equal to X, that means the user wants to exit. So we might say goodbye. And then we will use break to get out of this loop. So break is going to break us out of this while loop, and then we'll eventually exit the program. Now note that we don't have to check selection.lower or check for different capitalization because our menu function already calls .lower on the input. So the input is always going to have the spaces removed from the beginning and the end, and it's always going to be in lowercase, which makes coding this a little bit easier. Now what we want to do is ask the user to input those values for A and B. So we're going to call it X, and we're going to ask them to input the first number. And we'll input the second number as Y. Now we could call X and Y A and B, and that'd be fine, but it's usually better to try to use different variable names than what we did in these functions, just to make it a little bit clearer. It's not going to cause any issue. A and B would work completely fine here. I'm just going to call them X and Y, so there's no confusion when you're reading this about confusing them with A and B. And now we have to have an if statement to see which operation we're going to perform, because the user selected one. So if the selection is A, that means we are doing addition. So we'll have a result variable. And we're going to call our add function with the values from x and y for the user input. And then we're going to output the result. In this case, let's make it an f string. Result of addition is, and we'll put the result right here. Now we have to do this for each possible operation. Again, I'll fast forward this as I type them out. Okay, so we've typed out all the possible menu options, and I'll also add an else here just in case the input is invalid. And we'll add an extra line break onto the end of each one of these, just to make the output a little bit nicer in the console. Okay, I think we all have line breaks now. So we have the A case here. Let's make this a little bit easier to read. We have the B case for subtraction. We have the C case for multiplication, the D case for division, and anything else will result in invalid input. So let's review how this works. If we're running this module directly, we're going to call main. Main is the entry point for our program. In main, we're going to run this while loop that's going to run forever until a break happens. We're going to get input from the user, and we're going to use the menu function for that. That's the one we made in calc here. That's going to output all these lines to the user. And that's going to take their input, strip out the extra characters, or extra spaces, rather, and then convert it to lowercase. That output comes back and is stored in selection. If the selection was X, which is the exit case, we print out goodbye, and we hit break. Break causes us to exit this while loop, and then we get to the end of main and the program finishes. Otherwise, if we didn't put in an X, we ask the user for their first number and the second number. Then, based on their selection, we choose a different operation. If the selection was invalid, we type out invalid input, try again. The loop then restarts, and we ask them again for their selection. So this will keep going until they input an X. Let's give it a try. And when we're testing a program, we should try to execute all these different paths the code could take just to make sure everything is working correctly. We don't want to just do one run through and assume everything works. So we'll start with addition. So last time we tested it with 10 and 5. Now we'll try with some other numbers, maybe 20 and 30. And we get 50, which is the correct result. And it's waiting for another input. We'll say we're going to try subtraction. In this case, we'll see if it works for making a negative number. So we have 10 and 100. And we get minus 90, which makes sense. Let's try multiplication. So let's try putting in some floating point numbers, 1.5, and we'll put 5. And we get 7.5, which makes sense. Now we'll try division. So we'll say 100 divided by 2, get 50. I'm going to try division again. Maybe let's see if we can make it result in a floating point number. Get 5 divided by 2, 2.5. And we'll try division for that case where we divide by 0. Oh, we caught that error. It says error cannot divide by 0, and the result is simply none. Looks good. And then we'll try some invalid input. But notice that it is asking us for the number still, even if we provide invalid input. It still works fine. It says invalid input, but it did ask us for the numbers again. It's not really a problem. It's not an error in our code, but maybe we could restructure the code to be a bit better. And then lastly, we'll try exit. And that works correctly. So in this case, our code seems to be working fine, and I can't stress enough that you should try every single path for your program. So if you have an if statement like this, you should try it with test cases that would execute all of these different cases in the if statement before you assume everything's working okay. In this case, everything worked fine, except there was that one thing that was a bit awkward where if we put invalid input, it would still ask for the numbers before saying invalid input. And that's because these inputs happen before we get to that else case. If you wanted, as an extra activity, you could try reformatting this code. To do that, check first. It's not as elegant looking that way, but you could do an extra if here that checks if it's not equal A, B, C, or D, and then it causes the loop to continue in that case, which would restart the loop rather than break out of it for invalid input. But again, if you want to try that, that is a good homework activity. We'll switch back now to the slides. And we're back to the slides. And now, if you're following along with the PDF, I do have the solution in there, as well as attached to our learning management system as an actual Python file. In this case, it would be two files, calc.py and example 5.7. That's all I have for you in this video. In our next video in the series, we're going to talk a little bit about variables and scope. So please don't miss that one because it is important for developing with functions. Thank you for watching and have a great day.